This begins our lectures on section 3.4, using the slope to graph a linear equation. Our objectives are to know that m represents the slope and y equals mx plus b, how to graph using the slope and y-intercept, how to find an equation based upon the slope and y-intercept, to know the relationship between slopes of parallel lines and between the slopes of perpendicular lines. So our first topic that we're going to introduce is one that I've already talked about, the fact that the form of a line, form of a linear equation that we've been talking about, y equals mx plus b, in that form of the line, which is called a slope-intercept form, the b is the y-intercept, as we found earlier, where the ordered pair for that is 0b. X and y are the variables, and m is the slope. That's the numeric coefficient of the x. So we're going to do just a couple of examples to practice that, and then we're going to go ahead and make a graph from these. Although that doesn't come in until a little bit later, I'm going to do it here as well. So our example 14, it says, what are the slope and the y-intercept of this line? So my line here, y, is equal to 6x minus 4. When we look at this slope-intercept form, what we have is the y-intercept given by the constant that includes its sign. So that's our b. And whatever the numeric coefficient of the x is, that's our m. So m is equal to a positive 6. And remember that when we say positive 6, what we really mean is a rise of 6 to a run of 1. And then our y-intercept, our b, is equal to a negative 4. And remember, I really do prefer those given as an ordered pair, as a 0 and a negative 4. So what I would like you to do is I would like you to take a look at the next example, example number 15 here. Put your computer on pause, or the video on pause, and I want you to give the slope and the y-intercept of this equation. Y equals negative 2/3 x plus 3. Okay, go ahead and pause. So our slope, remember, is the numeric coefficient of the x, and our y-intercept is the constant with its sign. So the slope of this line is m is equal to a negative 2 over a positive 3. Negative 2 rise over a positive 3 run. And our y-intercept, our b, is equal to a positive 3. Again, remembering that I really prefer that to be written as 0, comma, and then our b, which is 3. All right, now let's go back and let's graph this line based upon this equation. So we're going to go ahead and we're going to put in the coordinate system. Oops, that was not a very good straight line there, but you'll get the picture. Here and here, and I'm going to first off put in my y-intercept. So I'm going to graph the negative 4 here. 1, 2, 3, 4 down. And there's my y-intercept, and I'm going to label it with a point. And then, or with an ordered pair. And then what I'm going to do is I'm going to use my slope, and you noticed how I've written it here as rise of 6 and run of 1. I'm going to use that to get a second ordered pair. Rise 1, 2, 3, 4, 5, 6, and over the 1. And that is x is equal to 1, and y is equal to 1, 2. And now I have a second ordered pair. And then from there, I could go back down this way and back this way, because remember, a positive 6 is also a negative 6 over a negative 1. And that would give me my 3 points, and I could graph this straight line. Now, I don't have a big enough coordinate system to show that for a slope of 6, so I'm just going to go ahead and draw this line with the 2 points, remembering that, of course, with any 2 points, you can draw a straight line, and of course I have no straight edge to do this with, so I'm going to have to do the best I can. And the last thing that I want to do is I want to label that with its name. So we'll do this again a little bit later on in this section, but I wanted to show that while I had this example going right here with why we're looking for that slope and y-intercept.